Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving trapping rainwater. I will go over 2 ways to solve this problem, but we'll only go over the coding for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given n non-negative integers representing an elevation map where the width of each bar is 1. And we want to compute how much water it can trap after training. So if we look at this example, the result is 6 because the width of here is 1 and the height is also 1, so that traps 1 unit of water. And right here we have 4 units of water, and then right here we have another unit of water that it can contain. So then if we add 1 plus 4 plus 1, then the result is 6. So then we return 6 for this example. So how can we solve this problem? One way that we can solve this problem is that we can set up a nested for loop. As you can see, the width of each index would be 1. And the length will be determined by the minimum of the max height on the left and the max height on the right. So for example, if we can look at this one, the max on the left is 1, the max on the right of this index is 3, so the height would be 1. Over here, the max is 2 and the max is 3, so the length would be 2, but you subtract by 1. And right here, the length is 2, but you subtract by 0. Right here, length is 2, subtract by 1. And right here, length is 2, subtract by 1, so then that will add to 6. So how this approach would be to loop through each index, and at each index we will have to loop again to find the max on the left and the right, and that would take a time of n squared, where n is the length of the list. However, there's actually a more efficient way to solve this problem, and I'll go over that way right now. A more efficient way to solve this problem is that we can set up 2 pointers, and then we'll have an initial right max and an initial left max. So the initial left max is 0 because there's 0 gray squares on the left, and the initial right max would be 1 because there's 1 gray square on the right. And if the left max is less than the right max, then we will shift the left pointer, and if the right max is greater than the left max, then we will shift the right pointer. And if the left max is equal to the right max, then we will also shift the right pointer. And there will be 3 steps involved with each iteration. So the first is that we will shift the pointers, then we will calculate the new left max or the right max depending on which pointer that we shift, and then finally we will update the resulting amount of water that it can contain. And we will continue this algorithm until these 2 pointers meet somewhere in the middle. So let's go over this example. We have the left max and we have the right max. The left max is smaller, so we shift the left pointer, and now we updated the left max. And then we update the result. The result is still 0. And how we can calculate the result is we can subtract left max or right max depending by which pointer that we shift by the number of gray squares in the current index. And we add that number to the current result. So right here, 1 minus 1 equals 0. We add 0, so the result is still 0. And now, because the left pointer and the right pointer are equal, so we shift the right pointer. Because we shifted the right pointer, we subtract right max by 2, which is still 0. And now 1 is less than 2, so we shift the left max. We subtract left max by 0, which is 1, so we add 1 to the result. And now, because the left max is less than right max, so we still shift the left pointer. Now right max and left max are equal, but 2 minus 2 is 0, so we add 0 to result is still 1. Now they're equal, we shift the right pointer. Now we subtract right max to the current index, which is 1, so 2 minus 1 is 1, and 1 plus the result, which is 2. And now that the right max and left max are equal, so we still shift the right pointer. The right max minus 2 is 0, so no change. And we shift the right pointer, update the right max, subtract right max to the current index, 3 minus 3 is 0, so no change. And now left max is less than right max, so we shift the left pointer. Left max is the smaller of the 2, so left max minus the current index is 1, so 2 minus 1, which is 1, so we add 1 to the result. And because left max is less than right max, so we shift the left pointer again. Now we subtract 2 to 0 because the index is 0. 2 minus 0 is 0. Add 2 to the result, so now that's 5. Left max still less than right max, so we shift the left pointer. 2, the left max, minus 1, it's equal to 1, so add 1 to that, and the result is 6. Because left max is still less than right max, we shift the left pointer again, and now that they meet, we can return the result, which is 6. So the time complexity of this method would be O of n, where n is the length of the array because 2 pointers may go through the entire array, which the length is n. And the space complexity would be O of 1 because we are not using any extra space in this problem. So now let's get to the coding part. So we'll set the left pointer to 0, set the right pointer to the length of height minus 1, We'll set the starting left max to the height on the left, so height of left. And we'll set the starting right max to the height on the right, so height of right. And the starting result will be 0. And now we'll set the while loop, so while left is less than right. And if the left max is less than the right max, then we will shift the left pointer, so left plus 1. And then we need to calculate the new left max, so left max equals the max of left max, or the height on the left, so the new left that we shifted to, and then we add the result, so result plus the left max minus the height on the left. And else, if right max is equal or less than left max, then we shift the right pointer, so right minus 1, and the new right max would be the max of right max, or the height on the right. And then we need to add to the current result by adding right max minus the height on the right. And once this algorithm finishes in the while loop, then we can return the result. So return res. Alright, let's see if it works. Perfect. Well, I hope this was helpful. I thank you all for watching. If you have any other questions or comments, please feel free to leave it down in the comment section below. And I hope to see you all again soon.